हेलो, गुड इवनिंग। दुष्यंत कुमार ने काफी पहले लिखा था, बरसों पहले लिखा था कि हो गई यह पीर पर्वत सी पिघलनी चाहिए, इस हिमालय से एक गंगा निकलनी चाहिए। तो वो हिमालय उनके दुख दर्द का हिमालय था। लेकिन अभी जो हिमालय है वो वाकई वो खुद दुख दर्द में है। और जिस तरह से जो पर्यावरणीय प्रभाव है, जो जलवायु बदलाव है, उसका जो असर पड़ रहा है हिमालय पर, उस पर बात करने के लिए आज हमारे साथ हैं डॉक्टर कलाचंद सेन, जो डायरेक्टर हैं वाडिया इंस्टीट्यूट ऑफ हिमालयन जियोलॉजी के। हमारे साथ हैं मिरियम जैक्सन, जो प्रोग्राम कोऑर्डिनेटर क्रिस्फियर इंटरनेशनल सेंटर फॉर इंटीग्रेटेड माउंटेन डेवलपमेंट, नेपाल से हैं। हिमालय एक नया सा पहाड़ है। जैसे कि अभी जहां हम बैठे हैं ये अरावली रेंज है, 3-4 अरब साल पुराना। विंध्य पर्वत जो हमारा है वो 3-4 अरब साल पुराना है। लेकिन हिमालय 4-5 करोड़ साल ही पुराना है। और ये इसको हम थोड़ा सा ताजा पहाड़ कह सकते हैं, नया पहाड़ कह सकते हैं, जिसके नीचे की टेक्टोनिक प्लेट्स आपस में टकराती रहती हैं और उस पर हलचल काफी रहती है। और इस हलचल के साथ में जब हमारे ऊपर की हलचल मचती है, जब हमारे डेवलपमेंट्स बहुत होने लगते हैं, जब हम उस पर टूरिज्म जरूरत से ज्यादा बढ़ा देते हैं, हम उसके ऊपर बांध बनाने लगते हैं, और फिर उनके प्रभाव से और जो ग्लोबल वार्मिंग है उसके इम्पैक्ट से जब वहां पर ग्लेशियर लेक्स बनने शुरू होती हैं, तब खतरे शुरू होते हैं। और खतरा सिर्फ हिमालय तक नहीं रहता। अभी जैसे हम लोगों ने पिछले कुछ सालों में देखा है कि ऋषि गंगा में जो बाढ़ आई थी, जो एक ग्लेशियर फटा और उसके साथ जब नदी में पानी आया, और तो उससे कितनी भारी तबाही हुई, सैकड़ों लोग मरे, और हरिद्वार तक गंगा का पानी 2 मीटर ऊपर चढ़ गया था, आसपास के गांव सारे बह गए थे। इसी तरीके से अभी केदारनाथ में जो तबाही आई थी कुछ साल पहले, हजारों लोग उसमें मरे। और वक्त समय समय पर आता ही रहता। अभी ताजा भी काफी उदाहरण है, जोशीमठ का उदाहरण है कि कैसे वहां पे धंस रहे हैं, शहर के शहर धंसना शुरू हो गए हैं। और ये खतरे ऐसे नहीं है जिनके बारे में पहले से नहीं बताया जा रहा है। पिछले 20-25 सालों से ये बातें हो रही थी, और जो बातें हम लोग लिखते थे और जो अंदेशे हम लोग जताते थे, वो हमारे सामने होते हुए दिख रहे हैं। तो सबसे पहले मैं कलाचंद सेन जी से जानना चाहूंगा कि ये जो हिमालय के ऊपर जो डेवलपमेंट्स हो रहे हैं और तमाम काम हो रहे हैं, आखिर इससे गवर्नमेंट सचेत क्यों नहीं होती, और लोकल लोगों और जो स्थानीय लोग हैं वो इस बारे में क्या करते हैं? बात करके फिर
Good evening to all of you. First of all, thank you, Sudhir ji. This is a very important issue that in Himalaya, we have been experiencing different kinds of disasters with variable intensities. At one hand, on other hand, we are seeing a lot of developmental activities. So the challenge before us lies that whether we should go for development, whether we should increase the fragility of the Himalayan, that he explained by the convergence between Indian plate and Asian plate. The Himalaya has been evolved in the past 55 million years back. So lot of implications we need to understand, then only we can give answer to this question. If you look into the developmental activities, people living into the Himalayan states, they have aspirations for the roads, tunnels, tracks for the rail, that flyover, or maybe some sort of ropeway, so that they can connect from their villages to cities and they can earn their livelihoods. That is one aspect. And there are plethora of resources also, if we look into the Himalaya, and that can be utilized for the socio-economic development. So we see the plethora of resources are there, we see that people's aspirations are there, and government duty is to fulfill the aspirations of the people. How it will be done? Whether we should go for all these activities or we should stop it. The challenge lies before us, how much we should do. At one hand, we are seeing that it is being affected by different kinds of disasters. On the other hand, we are seeing some sort of developmental activities which is needed, required. But what is the crucial question that optimally we have to utilize those resources so that at one hand, we can meet the requirement of the people, and on the other hand, we can save or preserve the fragility of the Himalayan environment, ecosystem of the Himalayan environment, biodiversity of the Himalayan environments. Anything, whenever you make a disturb, some consequence impact will be there. And in the present day, climate change is making huge impact to our health security, water security, energy security. And we need to look into all those aspects in a holistic way, not only the climatic factor. We need to understand what is the natural processes going on, what are the changes going on into the landscape and geomorphology, what are the different anthropogenic activities, how much extent they should go for. I will give one example in the Joshimath when 2023 beginning, it happened that subsidence as well as landsliding as well as development of the cracks. We visited that place many times. Still, we have been doing a lot of experiment, a lot of works to understand or link between the subsurface phenomena with the surface observations. And we asked some of the people, those who are living into that area, when you have a road and finding out there is a crack development, why you are constructing 2 more floors on the one floor? Then he answered that he has 3 or 4 sons. They don't have any job. Initially, he started with just selling tea and some sort of snacks, but profit came because a lot of pilgrimage, lot of people are coming into that region. He started thinking that why not open a restaurant in the first floor? So did that, again earned. Then second floor, he was starting to make a hotel or some sort of for the residents. So this is his plan because he is thinking that is the only way to get the livelihood without thinking. So the problem lying on us, to educator, to the politician, to the journalist, to everybody, we need to educate the people how much we should do, how much and what will be our role to safeguard the incidents, the safeguard the phenomena being experienced into the Himalayan town, which is different from the town in the plain. So we should have some sort of guidelines, town-specific guidelines into the hilly region, town-specific guidelines into the plain will not work there. We have to follow certain building codes. Our ancestors were not fool. They were building 1 or 2 stories consisting of the wood or some sort of bamboo, light constructions material. But now we are making heavy constructions, heavy, many floors buildings. So why we're not learning from the past or our ancestors, what knowledge they have patented to us, that ancient knowledge. So my last suggestions in this answer to this question, that we need development. On the other hand, we need to conserve the ecosystem of the Himalaya when we have understood that it is the fragility. So how a fine balance between this economy and the ecology can be made, this is the biggest question. And for that, everybody, it cannot be done by single person. All people have to come at one platform. Whatever scientific knowledge we gain, that has to be percolated into the mind of the people living into that region, in the administrator, in the intellectuals, in the politicians, in the administrations. And then we have to take that this is our role. If we want to safeguard, if we want to build a climate resilient, if we want to build a disaster adaptable future for not only for us, for our next generation, we have to do that. We have to see how much money we have in our pocket. But if we have more money and that money brings some sort of adversities, we should not encourage that. So some strict rule, some strict building codes has to be imposed. Education is must. Education regarding what exactly happening into the local regions. The people living into the plain, they may not bother what is happening into the Himalaya. Himalayan people have to be known that what are the different activities this place is experiencing and what will be the consequence of those activities to us. And if we want to safeguard, to live disaster-free, to live resilient, climate adaptable, what will be our role? And that role we have to find out, we have to chalk out, and we have to strictly follow. Without that, I don't think we'll be able to safeguard the people living. Both we need.
डॉक्टर साहब, एक सवाल इसी से जुड़ा हुआ है कि एक तो हो गई लोकल लोगों की, लोकल लोग ऐसे करते हैं, अपने लाइवलीहुड के लिए करते हैं, लेकिन स्टेट गवर्नमेंट जैसे है, स्टेट गवर्नमेंट टूरिज्म को अपना सबसे बड़ा एक वो समझती है कि उसको इस तरह के जो भी स्टेट्स हैं कि टूरिज्म से ही उनको सारी उनकी इनकम है, और ये सच भी है। इसी तरह से जैसे दिल्ली और दूसरे आसपास के जो बड़े शहर हैं, वहां के लोग फ्राइडे रात होते ही भागते हैं पहाड़ों की ओर। तो ये जो ज्यादा भीड़ बढ़ी है, ज्यादा तेज गाड़ियां आई हैं, ज्यादा बड़ी सड़कें अच्छी बना दी हैं, एक तरफ तो ये डेवलपमेंट का सिंबल है, लेकिन दूसरी तरफ इसी भीड़ ने, जो इन सड़कों की वजह से जो भीड़ बढ़ रही है, क्या उसका भी कुछ इम्पैक्ट पड़ता है?
This is again a very good and important question. Definitely, what I told, when a region is fragile and if it has reached suppose some critical stage, if we put some load on that, load over a period of time, definitely that load will not be able to sustain by that region and region will collapse. That's exactly happening. Whatever we are experiencing in the landsliding, whatever we are experiencing into the these avalanches into that region, because of some activities are going on. So for that, what is to be done? Geoscientifically, we need to assess the vulnerability of the region and make some impact assessment. Without impact assessment, anything if we do for the growth of our country, socio-economy of the country, that will have impact. That's why I repeatedly say the balance, and that's what the balance can be done. Not only who are the government, actually that is another question we have to raise among ourselves. Who is the government? All of us are governments. So it is the responsibility of the all citizens, scientists, it is the administration, it is the decision maker, it is the politician, it is the intellectuals, it is the environmentalists, all have to play their role and make in a holistic way that what is to be done, what is not to be done, how much we should encroach for the benefit of the people living into that region, and beyond that, we can't do anything. If we do beyond that, there will be severe punishment. You have very rightly pointed out, there is no need of many multi-story building. There is no need. If there is an opportunity, we can widen the road. But where we don't have any opportunity, if you just forcefully try to open or widen the road, definitely there will be impact of the slope sliding or maybe slope failure, mass failure. That's what we have been experiencing into that region.
In addition to the buildings, there are a series of hydroelectric projects. I believe that is one of the main reasons why that region could collapse and maybe not only subsidence other landslides, huge landslides. I think that is one of the main reasons that is entirely because of the government intervention. Not really.
Yeah, this is again, that's what I have not mentioned that what are the development. When we saw developmental activities, it includes everything, whether it is road construction, what is hydropower project constructions, even some sort of thing people think that into that region, we can have some tunnel. Recently, you have heard about that Silkiara tunnel episodes. So for everything, if somebody says the tunnel is not required, hydropower project is required, I will say that is not the correct thing. But we have to do that, but we have to take precaution into that. The tunnel, particularly into the Himalayan region, tunnel, what is tunnel? Tunnel is underwent passageway excavated through soil and rocks. So before doing tunneling, we need to understand what is the strength of the rock and soils, number one. What is the stability? Is there any threat from the hazards into that region? Are we aware of all these factors? Are we doing any sort of reconnaissance survey? Where the tunnel should be there, what will be orientation of the tunnel, at what depth, what will be the size, what will be the shape, what will be the excavation methods, drilling, boring method, or simply blasting method. There are many ways. And if we do systematically scientific way, we'll be able to safeguard. So that's why the concern is that for anything we need, but excessively if we go beyond that, and if we do not have any sort of survey, scientific way, we'll be having the consequences of that. That's what we are experiencing. What Sir has very rightly pointed out. The hydropower project also will make impact. Even road also will make an impact. Tunnel also will make an impact. Even agriculture also will make an impact in the slope regions. So we have to have that. But how much? That is the we are not following. And for that sensitization to the people, education to the people is very much required, that we have to live in this place. We cannot go away from the place. And if we want to live within this place, what are to be done? How much to be done? So that education sensitization is very much required. And media, journalists, scientists, and policymakers, decision makers, as well as intellectuals can play a very, very important role. They have to stand together. Then government will come into picture, because no government can do beyond. Whenever there is some sort of activities, we go through some sort of report. And report, if there is a violation, again, it has to be relooked into that. So that question is coming nowadays, that how much we should do. The concern of our journalists, concern of our scientists, concern have to be taken into consideration, how much, where, and to what extent we should do that.
डॉक्टर सेन, आपने एडॉप्टेशन के लिए जो हालात नहीं बने उसमें कम्युनिटी, सोसाइटी, गवर्नमेंट्स किस तरह से अडॉप्ट करें, इसके लिए कुछ आपने स्लाइड्स भी शायद आपने रखी हैं। तो अगर आप कुछ उनको दिखाना चाहें तो लोग।
Already time is also very limited. I will just try to show some of the slides. Okay. Just still she sets the slides. I'd like to point it out that I have chosen a topic which is a very broad and it takes a lot of time. Climate-induced disasters into the Himalaya and plausible mitigations. So nowadays, in every forum, whenever we are meeting, we are talking about 5 or 6 words. What are those words? One is definitely climate change. Number 2 is this disaster risk reduction. Number 3, that green energy. Number 4, sustainable development. Number 5, economic stability. So if you think around these 5 words, then you can see that today what is the need and what we are talking about, everything is covered. Don't you think so? That if you talk about sustainable development, if you talk about green energy, if you talk about climate change, disaster risk reduction, and sustainable development, everything comes into that picture. So I have just chosen this topic and try to finish within the limited time. And as our moderator, Sudhirji has very rightly pointed out that Himalaya is stressed because of the lot of subsurface processes like convergence, exhumation of the rocks, tectonics, neotectonics, then deformation of the rocks in the subsurface going on till Himalaya is formed. Above that, there are a lot of surface activity, erosion, weathering going on. So Himalaya is stressed. This stress is further aggravated by the climate change induced extreme events, heavy rainfall, leading to flash floods, landslides, extreme snow precipitation leading to avalanches. And above that, we as a human being making some sort of impact, anthropogenic impact. In some, we are seeing that Himalaya is stressed from climatic factor, from anthropogenic factor, from the natural processes, and in turn, there have been a lot of changes. I'm talking about Himalaya, I'm not talking about the plain. And in that case, if you look into that Himalayan scenario, you can see there are a lot of changes into the landscape as well as the geomorphology, and that control the damage pattern whenever there is any disaster related to earthquakes, related to landslides, related to glacial lake outburst flood, related to glacier avalanche, etc., etc. So we need to understand geophysically, geologically, geomorphologically, structurally, that how these particular factors are controlling during the damage. And if we can understand that in a comprehensive way, not only looking into one factor, climate, but looking into all other factors in a comprehensive manner, we'll be able to understand the processes. For anything, we're talking about disasters. If we want to make a mitigation to the disaster, we need to understand the basic cause, root cause. And if we can target at the root, we'll be able to provide some sort of solution. Otherwise, whatever cosmetic solution we'll be giving without understanding the root cause, we'll be failing our duty, we'll be failing to meet the challenges what we have taken up. So that's what our biggest challenge lies, all of us, that we need to look into that. So when you look into the Himalaya, entire Himalaya will be a very broad, and each part is having different type of geology, different type of structure, tectonics. They will be having different concepts we have to look into. So let us concentrate only one state, Uttarakhand state, and which is affected most by different kinds of disasters with variable intensities in time to time. If you look back, then you can see that this region has been affected, as our Sudhirji pointed out, 2013 Kedarnath, that killed 6,000 people, inundated 5,500 villages, and 1 lakh pilgrims were trapped. And that massacre everybody knows, and still afresh, 2013 and today 2024, we can remember that. 2021, Chamole disaster, a huge ice rock mass. from that in that Ronthi gap floor, from 5,600 meter above sea level, it fell down to 3,600 meter Ronthi gap floor. And in the peak winter, when that ice mass, huge ice mass fell down at that much height, it got fragmented into pieces, melted, created slurry material. And the slurry material, when it happened into the high altitude and it came down along the slope, it picked up materials, that loose debris materials, so small water pockets, as well as some of the plants. Mass increases and velocity increases because it's coming down. Momentum. And the momentum is so huge. On its way, whatever it found, roads, bridges, disconnected villages. They destroyed the roads and bridges. They destroyed the hydroelectric power project in Reni village in Tapovan area. So this, and killed 200 people. These are all fresh. So we need to learn from all these what exactly caused that. And if we can learn the basic purpose, scientific cause, and then definitely we can employ that knowledge and translate into some process and product so that we can safeguard other catchment, other basins into the Himalayan regions. So learning from the past is very, very important to understand the present, and that will give us an opportunity to predict future. So this prediction of the future in the artificial intelligence and machine era is very, very important. And that's what we have been doing into the Dhaliganga Rishiganga catchment by placing some sort of web-based sensors and getting data into the satellite mode, into the VSAT data. And we are continuously analyzing and processing. And if you want to monitor constantly, then definitely human analysts cannot do the job. We have to take help of the machine learning. It can do the job 24/7 and find out whenever there is a threshold, it will give some sort of alert, warning. And if the warning comes before the event takes place, we can prepare ourselves, and we need to educate people, sensitize people, how they can keep themselves ready to face that consequences. So if we can do that, we have to live with that, and we'll be able to make some sort of this job in this case. So we have been talking about climate change, but what are the indicators of the climate change? If we look into the Himalayan perspective, indicators are very, very evident. If we look into the glaciers, we are seeing the glaciers are thinning, glaciers are melting, glaciers are retreating, glacier lakes are being formed, tree line and slow lining shifting upward. And if we look into elsewhere, then we can see sea level is rising, sea surface temperature is rising, land surface temperature is rising. And if it happens like that, then we can see its impact, that water scarcity, adversity to the energy, food, health, that much temperature we cannot sustain, will be having some sort of health related problem, issues. And climate variability, seasonal change, you are observing anytime something is happening. There is no definition that what we taught, we are taught in the school days, this is the period for rain, this is the period for plana, this is the period for this is the period for these things are not happening because of this climate change. And disruption of the biodiversity ecosystem are taking place, land degradation, and we are seeing its impact in the form of different calamities, consequences we are experiencing. So what are the way forward? We know all sort of things are happening, but the most crucial questions people will ask and we have to reply is that what are the way forward? For that way forward, I will share some of the plausible mitigation, some of the strategy we can follow so that we'll be able to give some sort of respite to the people living into these regions, so that they should not live away. They will understand, yes, they can live, they can fight against all these disasters. So that is the situation we have to do. And this is the responsibility for the entire community. Single person cannot do that job. Everybody has to come forward. People living to that region, people involved into the research, administrators, even if it's a government, everybody is under part of the government, according to me. If we really want to understand the disasters problem and want to give some sort of mitigation measures. So I will touch upon some of the important aspects that what we can do to glacier hazards, glacial lake related hazard, landslide hazard, flash floods, or some sort of climate change mitigation into that directions. So I will just, for the sake of benefit, skip some of the slides, and time is also very short. When you talk glacier, everybody knows glacier is nothing but a big ice mass which can move. And glacial lake, any water body that is formed by the glacial activity. It can form at the front of the, can you see the cursor? At the front of the glaciers, it can form at the side of the glaciers, over the glaciers, below the glaciers. And depending on the nature of formation of the lake, the nomenclature of the glacial lake has been given: subglacier, supraglacier, periglacial lake, etc., etc. My concern is that in one region, again, restricting to the Uttarakhand region, first of all, we should know how many glacial lakes are there, how many glaciers are there, what are the sizes of the glaciers, what are the sizes of the glacial lakes, what are the infrastructure available, habitation available into the downstream. If something happened into the upper reach, what impact it can make to those structures, lifeline, what are those? So we have to first look into all these parameters. How many people are living into the downstream? See if something happens. So these parameters, we should look into that. And with reference to the Uttarakhand Himalaya, we have prepared one inventory. That map shows how many glaciers, how many glacial lakes are there. All glaciers are not vulnerable, or all glaciers and glacial lakes may not pose threat to the downstream. We need to identify those lakes and those glaciers which may pose threat to the downstream. But how do we know? It's obvious because of size. When it is big, when there are a lot of infrastructure into the downstream, then those catchment, those basins we have to monitor, we have to look into. So we have found out some of the lakes which may pose threat. I'm talking only again Uttarakhand Himalaya, and I'll be showing that some of the lakes and some of the glaciers we have been monitoring. These are some of the glaciers in the Uttarakhand. You can see the cursor. Okay. Anyway, you can see that I'll dekh rahe na? Okay. So some of the Uttarakhand glaciers we have been monitoring, and if we look into the glacial lakes, these are some of the lakes out of many other lakes. The some of the lakes which may pose threat, and those lakes I am showing over here. Out of all these lakes, only one of the lake I'll show over here in the this area, Vasudhara Tal, and another lake I'll be showing over here is the Vilangana Lake. So why we are much concerned about these two lakes? Why not other lakes? We have been experiencing, we have been observing data from different lakes and found out these two lakes may create some sort of issues. What we experienced in 2013 Kedarnath and what we experienced recently in Sikkim, South Lonak, partial glacial lake outburst flood. If some similar situation may take place, again, we cannot predict. We are raising hands. We are doing some sort of study based on the data. We are trying to understand about the health of the glacier. To understand the health of any person, we have to go to the doctor. Doctor gives prescription for different tests. By having the results, outcome of the test, we can find out where is the problem. Is a lung problem? Is a liver problem? It is a heart problem? Whatever may be, that way. So we are looking into all these data sets, that geological data, geophysical data, remote sensing data. Based on that, an inaccessible region, mostly we have to depend on the satellite data, remote sensing data. We can't go there, but we have to look into those. So by looking into that, I will detail show about that what exactly happening to the glacial lake. Coming back to the one of the glaciers in the glacier, Gangotri Glacier, if you look into that glaciers and if you look into the satellite data, the frontal part we call snout of the glaciers, the mouth. And in the passage of time, you can see that particular glaciers, this much has been retreated. So over a period of time, how much it has gone back, and from that you can calculate the retreat. And we have found out that retreat rate is 15 to 20 meter per year into these Gangotri glaciers. And there is some sort of, you can see that Meru Bamak tributary. So when the glacier retreated, this tributary, lot of debris, lot of material went down. And 2017 it happened, but it didn't cause any damage to the property because in that catchment there was no habitations. So if there is no habitation, we don't find any hazards, we don't find any sort of damage, and we don't bother much. But wherever there is a habitation, there is some sort of lifeline structures, we need to monitor that region very critically. This is one of the issues. So what I was telling in this case, how we do different type of test. The test we do, we acquire different sets of data. If we consider one of the schematic lake into this region in a high altitude, and it is Himalaya, seismically active zone, there may be some sort of vibration due to earthquake, there will be tectonic forces, there will be some snow precipitation, there will be avalanches, there will be landslide, there will be glacial melt. And whatever capacity that particular lake has, the water accumulated into that lake may exceed. And if it exceeds, what will happen? It may spill over. Because this, and again, one more thing, the wall of the lake is not very concrete. This is made up of loose debris material. So there can be every chance of breaching of the lake, initially it will be very narrow, but when in the high slope region, the forces will be heavy, and then it will start widening. And when it start widening, the huge amount of, so we can understand all these phenomena, what exactly happening to the lake, about the health. And based on that, we can predict, we can forewarn that something is going to happen into that region. So that's what we have to place some sort of instrument and understand what is going on into that lake, what is going on into the glaciers, so that the related hazard can be avoided, the related hazard impact can be reduced to the structure, properties, lives, livestock, etc. So this is, I was telling the Vilangana Lake. This Vilangana Lake, you can see over here, and over that we have Kathleen Glacier. From our study, we have seen the Kathleen Glacier is thinning, and the glacier lake is expanding. So thinning means is the melting water is getting accumulated into the Vilangana Lake. And in the last 47 years, we have seen the lake has grown to 0.35 square kilometer area. If you want to convert into square meter, multiply by 10 to the power 6, you can find out that what exactly happened in 1976, 1980, 1994, 2011, 2015, 2021, the lake is expanding. So we are monitoring that lake to know that what is the capacity of the lake, at what rate the lake water is being increased, what is the material made up of the lake, whether they can, how much pressure they can sustain, and when it exceeds. So we are doing some sort of modeling, and that will help us. Again, there will be a lot of uncertainties, many other things. If we do not incorporate many parameters properly, our modeling can also give. But from the data, what we are seeing, that lake is being expanded, and there is a chance, and the lake is also formed at a high altitude at around 4,750 meters, where the slope is also quite large, 25-30 degree slope. So if lake exists in a high slope region and high altitude, every chance that entire water, if it started breaching, entire water will come down heavily. And that sort of what exactly we have experienced in the past may happen. I am telling may happen because we don't have right now any sort of data by which we will be able to tell exactly when it is going to happen. So this is some sort of examples. I just skip these slides because time is very short. What I want to say over here, that some of the incidents you remember 2021, that Daliganga, Rishiganga, we observed that particular glacial avalanche, huge ice rock mass fell down. And after that event, we did a lot of study, even in the post-mortem study, there is a nearby seismic stations, and we found out into the seismological data, the entire episode of the nucleation of the particular glacial avalanche, then debris formation, debris flow rate, damaging different type of bridge structures as well as hydropower project. Each has different type of frequency response. By looking into the frequency response and knowing, we could find out the entire episode of the event, of the glacial avalanche event. So that shows the seismological data. If we have closed network of the seismological stations, and if we constantly monitor, it will give us some sort of informations. So this is the very beautiful information we gathered in the post-mortem study after the incidents take place. This is the time where the avalanche took place. That's arrow you can show. And before that avalanche, 3.5 hours, we could see there are a lot of tremors. And before 3.5 hours, there is no such tremors. This 3.5 hours time, it is giving some sort of signal, something is going to happen. And this is called the precursory event. So we have stressed upon studying the precursory events by looking into the data in continuous mode. And if we find out the precursory events into the seismological data, generally we monitor from the hydrological data, from the meteorological data, to understand what is the sediment flask, what is the mass balance, what is the glacier recession, what are the water discharge, what is the temperature, what is the wind speed, what is the wind direction, what is the humidity. All these parameters generally we have been looking so far, but after this event, we are adding one more information, the seismological data, and this precursory event, if we can add, and if we look into continuously the hydrological data, meteorological data, and seismological data, and analyze them based on artificial intelligence, because I told that human analysts cannot do that analysis 24/7. We have to take the help of the machine artificial intelligence. And if we can find out this threshold, we'll be able to again give the warning alert. So that's what we are trying, and we are trying to develop into this Dhaliganga, Rishiganga catchment.
डॉक्टर साहब आप बाकी
Yeah.
कुछ हम
Just I will finish over here. We have been talking about subsidence, landsliding into Joshimath. We'll be coming to that whenever some discussion took place. Before that, in the rainy village also, in the post-mortem study, this is after the event take place, when you look into the geomorphological features on the remote sensing data, till date, we are seeing that lot of sediments, when it is going debris flow, it has made the toe cutting. So in a slope region, when a lot of debris is going down and it is making toe cutting, what will happen? This particular area is going to experience some sort of landsliding. And that is the situation we have been observing on the remote sensing data. So that shows that we need to do some sort of simulation into the lab to understand that what is the mass movement, what is the debris flow simulation into this region. We have done that, and we have found that huge amount of sediment have been flown down. And that particular also shows if it flows down, then what exactly happening into this region through which the sediment have gone down, what it is going to experience. So we need to collect some sort of data and monitor that region, and we have been monitoring into these regions also. I think I will just stop over here, only touching upon one example of the Joshimath, that after the incidents, we have been acquiring a lot of geological, morphological, structural data to know what is going on the surface, as well as a lot of geophysical studies, that the seismic studies, resistivity study, magnetometry study, to understand the link between what is going on beneath the surface and what we are observing on the surface. And we have understood from that study that in the Joshimath region, that the groundwater imbalance has been responsible for the development of the crack, for the development of the sinking, subsidence, subsliding into this Joshimath region, because there was good pockets of water, and that water in the JP colony flew down. And when there is that much amount of water and debris, loose debris material went down, that particular slope region got subsided. And it didn't get subsided uniformly. That's why, because of this differential subsidence, there have been development of the cracks. So this is the scientific explanation of the development of the cracks into this region and subsliding into these regions. I think I will stop over here and take some more questions. And climate change, energy is intertwined. I will come back maybe after some time, whenever we'll get an opportunity to talk about.
क्वेश्चन हम लोग अभी आखिर में लेंगे.
Thank you very much.
Thank you. बहुत ही अच्छा. तो अभी डॉक्टर सईद ने बात की ग्लेशियर लेक्स की और अर्ली वार्निंग्स की. तो हमारे साथ मिरियम जैक्सन हैं, जिनका एक्सपर्टाइज इसी में है कि मैनेजमेंट ऑफ ग्लेशियर लेक्स. Miriam, we have two questions to you. First, early warning system are how much efficient for glacial lakes outburst floods? And second, what are the challenges in developing such system, and what are the some good example to have worked for the management of glacial lakes?
Thank you. Two good questions. I think I'll answer them both together. They're effective 100% if they're done properly. And this is the challenge. And the thing is, to do them properly, you need to have a lot of knowledge of what's happening. You need to make sure you have the early warning system in a good place. And you also have to think about sustainability. And this is part of the problem. So there's experience from one site in Nepal where they're putting an early warning system with no consultation with the local community. And then the local community had no idea why the things were there. They decided to take them away in case they were worth something. In the same place it was then put back again, but then they were told they were responsible for the maintenance. So it's, you know, it was to protect them, but just to be sort of have this imposed on you is not the best way of doing this. So it's very easy to say, you know, we know this is a problem, we're going to go in and do something, but you have to work with the local communities and do it in consultation with them and make sure that they know why to say. Also make sure that they know what to do. You know, an early warning system isn't magic, it's a warning. What do? Do you get to high ground? Do you run down to the river's edge and get all your livestock first and then go to high ground? So there also has to be training in this as well. And this is part of the whole thing, that you do the monitoring that Dr. Sain talked about, and you do everything else. But also you say what happens in an emergency, that you have to have, for example, evacuation routes. You have to have a plan. You have to give training to people. You have to make someone responsible. So there's a lot of things that go into this. It's quite complex. And putting in the early warning system is just one piece of the jigsaw. Okay, so namaskar, everybody. Good afternoon. We had quite a lot of talk about heat waves early on this afternoon, so it's quite nice now to be talking about the cryosphere and glaciers and cool down a bit. This building might be nice and cool, but it's a bit too hot for me. I'm not used to this weather. So I'm going to be discussing glacial lake outburst floods in the Himalayan context and giving you a few examples, and actually not just sticking to the Himalayas, but also possibly going to the Hindu Kush a little bit every now and then as well. First, I want to say something about ISI mode. I think I've told a few people here who know about ISI mode. So I just very briefly want to say that we're based in Kathmandu in Nepal. We're actually working in 8 different countries in the region, including India. And in some countries, we're doing capacity building, and other countries, we're using people in that country to support capacity building elsewhere. It might depend on the topic. We might be working in one country where they need a lot of capacity building in something, but they're very advanced in something else. So we're really trying to do these different projects, different work in the Hindu Kush Himalaya, and use what we've learned and what's successful in one region and apply that in another region. We recently went through a restructuring. So if you knew anything about ISIMOD before, it's now totally changed. We're now we're made up into 3 strategic groups. I'm not going to go into a lot of detail, but just to say that under the strategic group are 2 action areas. And under the first one are these 2 topics, managing cryosphere and water risks and simulating action for clean air. And this is what I'm going to be talking about today, is managing cryosphere and water risks. And we're not really looking at cryosphere from the scientific perspective, but more how does that relate to risks, especially as the cryosphere changes. How does the hazard change, and then how does the risk change? And a little bit more detail, this is what we're doing in my group, which is managing cryosphere and water risks. And we're also trying to get a lot of regional cooperation going. You know, and you'll see a little bit more why later it's very important to have regional cooperation. Someone mentioned that this morning, that we don't just, you know, think this is India. A lot of things are transboundary, so we really have to keep that in mind. I've been talking about the cryosphere. I don't know if everybody knows what that means. It's just a very simple way of saying glaciers and snow cover and permafrost and ice sheets and all these things. Basically, water at the Earth's surface that's frozen, that's the cryosphere. And in the Hindu Kush Himalaya, we're especially concerned with glaciers, snow cover and permafrost, which is frozen ground. And a lot of the problems that we're seeing in terms of landslides and instability, especially at high elevation, is where the ground is frozen and now it's thawing and not as frozen anymore, and then it's a lot less stable. And we're seeing a lot of construction at high elevation, hydropower, roads, this kind of thing. And if you're building on permafrost, that's generally not going to go well. Some of the information I'm going to present is based on a report that we released in June last year. I know at least one person here has read it because it's quite prominent in the State of the Environment report that was released this morning. So that was very nice to see referred to there. And it's also available online if you haven't read it yet and want to see it. So we've been looking at the temperature in the Hindu Kush Himalaya over the past few decades. We've talked quite a lot about temperature change, but we can see this temperature change is definitely going on in some areas more than others. And the changes, when you think about them, aren't very big. You know, when you talk about a heat wave, you're talking about a big increase in temperature. But these changes, although they're very small, they're constant. You know, if you consistently have, you know, 0.5 or 1 or 2 degrees extra over several decades, that's definitely going to do something to your cryosphere. It's also a little bit different at elevation. So we talk about elevation dependent warming. What this basically means is that it's different at elevation. It's not necessarily more warming, but usually it is. And that's not very well understood. But if we look at see how much it depends on temperature, you can see here that in most of the Hindu Kush Himalaya, we've split this up into 12 different basins, by the way. So you can see in several of the basins, especially the Ganges, Indus, a few others, Brahmaputra, you know, as you get higher up, the warming's increased. So the warming you get at Delhi is not as much as the warming you're getting at 3,000 or 4,000 or 5,000 meters. And you see for Brahmaputra, it really increases when you get higher up. It's not the same everywhere. 1 or 2 places, Helmand, for example, there isn't warming elevation, or it's even a slight decrease. So we really have to be careful that, you know, we're seeing general patterns, but we're also seeing a lot of variation from one basin to the next. I like to show this just to show you how widespread the glaciers are in the Hindu Kush Himalaya. We also have permafrost on this map, which is actually done at a different scale. And this is because if they were the same scale, the permafrost would just totally overwhelm the glaciers. There's a lot of permafrost that it's very hard to see on satellite imagery. But we do know there's a lot of glaciers everywhere, even in, for example, Myanmar. Myanmar, they have glaciers. Not many people know that. So this is something, you know, this isn't something that's affecting just one country. This is affecting many countries and many different river basins. And I know this graph is quite complex, but it's a lot of really good information. This is the 12 different basins then of the Hindu Kush Himalaya. And we're looking at 3 different periods of how the glaciers have changed. And basically, if you have red, that means that there's melting, which isn't good for the glacier. If you have blue, then the glacier is getting bigger, which is great. And on this graph, you can see it's pretty much all red or pink. You can see one blue spot, and this is now reversed. The blue spot's in the middle period, 2000 to 2009, and then now that's gone to stable. Everywhere else it's melting, it's really red. As you go further east in the Hindu Kush Himalaya, Brahmaputra, it's really melting a lot. And we've seen a big change just from one decade to the next. So from 2000, the first decade of this millennium, and the second decade, the increase in glacier melt was 65%. And this is a huge change. Imagine if you have that change every decade, the glaciers are going to disappear very quickly. This is what it looks like on the ground. This is a glacier a little bit north of Kathmandu in Langtang Valley. We've been monitoring, or different groups have been monitoring it for quite a while. ICMOR's been monitoring it for just over 10 years. And you can see what was a glacier, and you didn't go fully into the definition, but I think most people know a glacier is a mass of ice that moves on its own weight. This is pretty much not a glacier anymore. It's just a big lump of ice that's not even big enough now to move, to be a glacier. So we're going to see this more and more. This is quite low down, this glacier, but we're going to see this more and more. These glaciers are just melting very fast. And what's going to happen in the future? It really depends on what we do. But even in a 1.5 degree world, you know, we're going to lose up to 50% of glacier mass by the end of this century. If it's more than 1.5 degrees, and we're definitely on track for more than 1.5 degrees, there's not going to be much glacier mass left in the Hindu Kush Himalaya by the end of this century, which is a long way away. But I think many people here have got children who are going to be alive then, or you're going to have grandchildren who are alive then. You know, there's people in this room who are going to see the end of this century, or at least have children who will see the end of this century. So this is something that affects all of us. So as the cryosphere changes, the hazards change as well. And I was involved in one of the IPC reports, the special report on ocean and cryosphere and a changing climate. And I really like this figure. It just says a lot. So this is the present status that you have. You have glacial lakes, you have snow and avalanches, you have permafrost, you have some infrastructures downstream. But what happens in the future? In the future, the permafrost thaws. You're going to have more unstable slopes and more landslides. You can get more avalanches. Generally, as we heard, there are exceptions. Unless there's pressure on you, people generally don't build where it's unsafe. You build where it's safe. You don't build where you know there's always avalanches. You build where there's not avalanches. But if the avalanches are changing, or if, for example, it's changing from a dry avalanche to a wet avalanche, which is wetter and more destructive, then who knows where to build? You know, things are changing. If you've never had a glacier lake outburst flood before, how do you know that you're building somewhere where one could happen? So these things are changing, and this makes it really hard. And also we're getting a lot more development downstream, including roads, houses, and hydropower. So we need to do 4 steps during the early warning systems. The first one is the risk assessment. So is there a risk present? How great is the risk? We need to monitor for a while. We've already heard that's very important. And then we need to do information dissemination. You know, we don't just sit there with information. We need to tell the local communities. We need to talk to government officials. We need to talk to journalists, because journalists are very good at getting information out. And we also need to do preparedness. If something happens, what do you do? These are the 4 essential steps. So as we heard, when the glaciers shrink, then you get glacial lakes being formed. There's thousands of them in the HKH. There's so many, it's a little bit hard to monitor them all. So you have to find ways of monitoring which ones are actually dangerous. Obviously, they tend to be at high altitude. So they tend to be somewhere where it's very difficult to access. You know, if something's at 5,000 meters, you can't just drive there with a bulldozer and things like that. The communities downstream need to know about these things, but sometimes they don't want to move. where are they going to move to? You know, these are the homes, the livelihoods, everything. We're working in Western Nepal, in Humla, and there's a very old monastery there and a very important monastery. And the people there said, you know, we can't leave the monastery. This is important to us. So they've had one glove already. At some point, they'll probably get another one, but they're saying we can't move. So you have to take that into consideration. You can at least put in early warning systems, for example. So there's a few examples here of gloves that have happened and what's been affected. There's been quite a few already, and you can see how destructive they can be. There's often several million cubic meters of water and often sediment as well, as we've heard, so they're very destructive. This is an interesting one. The origin was Gongba Tongsha Glacial Lake when it damaged the Botakushi hydropower plant. Does anybody here know where Gongba Tongsha Glacial Lake is? Any ideas? Is everyone really shy? Does anyone think it's in Australia or Canada, France? Any guesses? Okay. Okay, we'll get back to that. Botakushi hydropower plant, who knows where that is? France again? Okay. Okay, I'll tell you. Gongba Tongsha Glacial Lake is in Tibet. So this is in China. Botakushi hydropower plant is in Nepal. Here we have a little bit of a dilemma. So we can talk as much as we want about what you can do about mitigation. You can drain the lake, you can go to the lake, put in early warning systems. But if the community affected is in Nepal, you're not going to be able to just walk into China and do a lot of work. And this is, you know, a lot of these hazards are transboundary. And someone mentioned this morning with ecosystems. And it's the same with the cryosphere. The cryosphere tends to be at the highest point because it's cold, and the highest point is usually the political boundaries on the map. So the cryosphere doesn't recognize the political boundaries. You have a lake in one country, you have the damage in another country. And this is something that we see a lot of, that a lot of these risks are transboundary. That makes it even more challenging. How do you do mitigation? How do you go in there and lower the lake or put in early warning systems when it's in a different country? Bhutan's another nice example. In Bhutan, there was a big lough in 1994. It killed about 12 people, I think. It killed some cattle or other animals. It damaged land. It also took out the most important monastery in Bhutan at Punakha. And so they decided that they had to do something about it because the lakes were building up again. And in the early 2000s, you know, they realized this was a risk and they had to do something about it. But it was at 5,000 meters. So it's the same country. There's no transboundary problem there, although it was very close to the border with Tibet. But how do you go up to 5,000 meters? You can't drive a bulldozer up there. So what they did, they took about 300 manual laborers up there each summer for 4 summers in a row. I think trying to control 300 people was quite a big challenge, but they did actually manage to lower it by several meters, and lowering the lake level by 5 meters is several million cubic meters of less flood volume. And they've also put in early warning systems. So this is downstream now, near Punakha, actually, just a little bit downstream from Punakha. They've also had 1 or 2 cases where it's gone off, and that was good, protecting them from floods. There's also 1 or 2 cases where there's been false alarms. This is another problem with early warning systems. You know, a false alarm is very dangerous. You have too many, people just ignore it. So this is something else to take into consideration. Imja Lake is one where a lot of things were done without much consultation with the local community. So there was a lot of important work done here. There was also a lot of lessons learned of just, working together with local communities. And I don't want to say too much about South Lanark Lake. I know the next speaker is going to talk about that, but I just want to say a little bit. So I know a colleague called Ashim Sattar, and he's done quite a bit of work on South Lanark Lake. He had a couple of publications in 2019 and 21, I think this is, looking at the problem, not just South Lanark Lake, actually there's 1 or 2 other lakes in the same area. He looked at how big the flood could be, what could trigger it. There could be an avalanche into the lake. I first met him at this conference in Almaty in Kazakhstan in November 2022, when he gave a presentation all about the work he'd been doing and about how dangerous this was, South Lanark Lake plus one other lake in Sikkim. There was also previous work there, so people knew this was a problem. In 2016, there was people from the Ice project. This is Sonam Wangchuk, if anyone knows him. And they went there for several weeks. They took up these like 3-meter long pipes on the back of yaks. Here you can see that. I don't think the yaks were too pleased. It's not the usual loads they were carrying. Again, these, you know, wherever the glacial lakes are is usually very inaccessible. They went up to the lake and tried to drain it by several meters. The army was also involved and was working with them. And then the work stopped a little bit. And then they started putting in an early warning system in the autumn last year. And they didn't quite get finished. So they started putting it in, but they hadn't done 100% of the work. It wasn't working correctly. And, you know, it hadn't done anything for a long time. They probably thought they had more time, but they didn't have more time. So in October 2023, all the glaciologists were looking at the satellite images, trying desperately to see what had happened. And they could see there'd definitely been a change from the end of September to early October, that something had happened at the lake. It's not a cloudburst. I know a lot of people thought that originally. At least there's no evidence of there being a cloudburst. So it's very unlikely it was a cloudburst. But if you look at the side where the lateral moraine is, this collapsed into the lake and triggered it. So it's very interesting with glacial lakes because the theory says it gets to a certain level and then the dam fails. And I often think that the glaciers don't actually read any glacier textbooks because it gets to a certain level and nothing happens. And then something comes along and triggers it. Often it could be heavy rainfall. I've seen that many times. It could be an avalanche or rock slide into the lake, and then that just sets the whole thing rolling. And we've already talked about hydropower a couple of times. Obviously, this one affected the hydropower downstream, Tista. There's a couple of others I showed that also affected hydropower. And it was very nice to hear Sunita say this morning that hydropower is not necessarily a problem. If you put in the hydropower and you don't take these things into consideration, it is a problem. But I worked over 20 years in Norway on gloughs, and a lot of times the hydropower companies have a reservoir, and a glough happens, and they say, "Oh, the reservoir's gone up. We've now got another $20 million, whatever." You know, so actually then the hydropower then protects the land because it takes away the water from the reservoir. There was one case where they asked us to go and look, and I went there, and it was unbelievable. I mean, it looked physically impossible. You know, the water was so high compared to the glacier. And we said to the hydropower company, you have to drain your reservoir. Something's going to happen. So you seem to the hydropower company throw away lots of money and trust us. And the hydropower company did trust us. They lowered it. And actually the reservoir was 3.5 million cubic meters. The flood was 5 million cubic meters. So the flood was bigger, the volume of the lake, but it just meant it was more controlled. So it didn't cause a lot of damage. And I think South Lanark is interesting. I think to me, it's a corollary for the climate crisis. We know there's a problem. We know what should be done, but I don't know if we're acting fast enough. So we've been working on looking at all the recorded gloughs in the whole of the Hindu Kush Himalaya, actually also in other parts of high mountain Asia into Central Asia. And there's been a lot of gloughs, 436 recorded gloughs. And here, this is how they look in the different kinds. So a lot of them are ice dammed with the lake at the side of the glacier. A lot of them are moraine dammed with the lake in front. We tend to see more moraine dammed in the eastern and central Himalayas and more ice dammed as you get further west into the Hindu Kush. But there's one thing that I want you to notice about this graph. You can see the numbers increasing. And I think this shows very clearly that we're getting better at recording them. You know, there might be more, but we don't know. If there was a glough 100 years ago, you know, who went up to have a look at it and who did you tell? So I think this is something we have to be very aware of. There's certainly more glacial lakes. There's probably more gloughs, but we're getting a lot better at recording them. So these kinds of graphs, I think you have to be very careful about reading them. This has already been discussed a little bit. You have to then look at the different glacial lakes and try and assess them. How big is the lake? What's the dam like? Is it a good dam or is it a very fragile dam? What's the source glaciers like? You know, is the avalanches coming in? And then look at what's happening downstream as well. How many people are living downstream? I've seen several gloughs in Norway. They go straight into a fjord. You know, no one notices it happened. Here, you know, it could go straight into a huge hydropower plant and affect several roads. And before I gave this talk, I was communicating with Ashim, who I mentioned already, and he just come back from fieldwork in Sikkim and said the damage is just incredible. You know, when you think this is something we knew about and we didn't act fast enough, it shouldn't be like that. So we have to really think what's downstream. You might have quite a small lake. It might not be very dangerous compared with some, but if you have a lot of people downstream, then that's going to be higher priority. So you can do this, then you can classify the glacial lakes, you know, which ones are dangerous in terms of the volume, the surroundings, the people downstream. And then we can use machine learning, but generally we don't have the capacity to monitor closely hundreds of lakes, but we can try and narrow it down and say, these are the ones, these are the few we should monitor and really concentrate on them. So what we did, we put all this information into a dashboard. So you had a dashboard mentioned this morning. This is the second dashboard of the day. And this is to do with GLOFs in high mountain Asia. And if we think about Lanark, you know, how come the scientists knew things and tried to talk to policymakers and government officials, but the information didn't get through? What's the missing element? And one missing element could be the media. You know, if journalists can really push this, that helps a lot. So we need to have journalists on our side. So we want you to use this dashboard. And you can go in and search it in different ways. This is a URL, so you can use it. And you can look at different countries, you can look at different years. I've just done a search here, so this is why there's only a few countries coming up. And I'd put in, I looked at an example in Bhutan, and it'll give you all the information we have on it. We might not have all the information we want, but what we have, we put in there when it occurred, where it occurred, how high was the lake, how many people died, how many yaks died, how many bridges were destroyed. All the information goes in here. And now I'm going to give you some homework. So I would like you to go and use this because we've done a lot of work, we've made this, and now we want to know if it's useful. And this, you know, so I'd really like you just to go in there. And if you're sitting at the back thinking, oh God, this is so boring, I don't care about gloves, this is too technical, we especially want you, because you're the ones that we really want to reach. So we don't want a lot of people to just sit this in, oh yeah, this is great, yeah, whatever. You know, if you have critical things to make it better, let us know. We do know this isn't the final product. We're working on this. There's a lot of improvements we already know about, but we just want you to have a look at this and use it. I think there's also people watching online. This is you as well. Please send this to your colleagues as well, anybody else, you know. So we've developed it from quite an academic perspective, but we don't want to reach just academics. We want to reach a lot of other people as well. So this is your homework for the next couple of days. Thank you very much.
थैंक्स मरियम। तो मरियम जैक्सन ने भी बताया कि जो साइंस है, साइंटिस्ट हैं, वो उन्होंने पहले से बता रखा था। जो अभी ये जो मणिपुर में साउथ लोनाक में जो हुआ सिक्किम में, तो वो कितना पहले से उसके बारे में पता था और साइंटिस्ट ने बताया हुआ था, लेकिन जो हमारी अथॉरिटीज हैं, गवर्नमेंट हैं, उन्होंने उसको उतनी गंभीरता से नहीं लिया। और उसका असर सिर्फ वहां पे नहीं हुआ कि खाली एक ऊपर ग्लेशियर टूट गया, नीचे 1200 मेगावाट का जो नीचे नदी के ऊपर जो डैम बना हुआ था जिससे बिजली हो रही थी, वो भी पूरा चला गया। तो मणिपुर में जो हुआ उसके बारे में बताने के लिए हमारे साथ ऑनलाइन जुड़े हुए हैं डॉक्टर पीडी राय। पीडी राय जी सिर्फ मेंबर ऑफ पार्लियामेंट नहीं रहे हैं, बल्कि वो एक पहले मेंबर ऑफ पार्लियामेंट थे जो आईआईटी कानपुर से उन्होंने मैकेनिकल इंजीनियरिंग में इंजीनियरिंग की है, साथ में आईआईएम अहमदाबाद के भी पास आउट हैं। तो आप उनके नॉलेज का अंदाजा लगा सकते हैं कि वो कितने, उनको अपनी फील्ड के बारे में कितना पता है। Mr. Rai, our question is, what is the impact of recent glacier outburst in Sikkim?
Okay, first of all, let me thank Sudhirji for moderating this panel, and I've been listening with great interest right from the beginning. Dr. Kalajin Sen, who's a dear friend, and we've been interacting at the Integrated Mountain Initiative programs. I was the I've just I'm the past president of IMI, and presently there is a caveat. I'm also very much involved in the 2024 election. So, do consider that as one of the reasons why, it's been, I'm not there with you, even though I would have liked to. I'd like to thank the organizers, and especially Sunita ji for inviting me to this panel. Miriam has given a very extensive, presentation on why gloves happen, how do they happen, and what are the impacts and what we can do about it. And I think the basket case has, as she has pointed out, has been Lonak. And to tie it up with the question that I need to answer is what has been the impact of that glove? It is just so it's just been a very devastating. It's just been so devastating that and I've lived through it. So it's interesting that the early morning, when we got the information, it was around 3 a.m. that we got the information that something terrible has happened and the Tista is flowing with all ferocity, and it has kind of the damage is huge. We started looking for more information and data. And when I say we, it was at that time I was working with a group of my colleagues in the Sikkim Democratic Front Party. And so we, as quickly as the morning of the 4th of October 2023, we rushed down to a place called Singtam, which is the easiest and the quickest way to reach the Tista. And what I saw there, I've never seen in my own living memory. The Tista flowing, even though many hours had elapsed, the Tista was still flowing with a ferocity that I've never seen before. So it's a personal story, which, and then we gradually made our way into the various places and found the panic-stricken populace of Tista, of Singtam, who had moved to higher ground. But we were told of tales of how houses got swept away, how people got swept away, how bridges got swept away. And, there's a story of one person who actually, because there is a school, a government senior secondary school, which is a little on the higher end of Singtam, and that had to be opened up for all the people who were being moved to safety. And there's one young person who went across a bridge just to get the key. And he had driven all the way across, got the key, along with a co-passenger. He was coming back. He was on the bridge when the bridge was swept away. And so there are some of these very difficult stories that is there right from Lachen up in the north of Sikkim, along the Tista Basin, Chungthang, which is completely devastated, and that's been documented by somebody who works on landslides from Kalimpong. His name is Wing Commander Praful Rao. In his blog, you will find this entire, the Tista Basin, how it got impacted, is available there. So if anybody wants to do that, you can go to his blog spot and I can share the details of that. But what has happened is that now, coming fast forward till today, Lachen, a tourist center, and from where many people go all the way up to Guru Dongmar, which is at about 17,500 feet, to see that particular holy lake. and it is also the start of the River Teesta. So this this particular Lachin town, a very bustling tourist town, is now today a dead spot. From the time the road and with it a whole convoy of army trucks, ammunition dump, etc., all the ammunition taken down, all that road is yet not been rebuilt. I mean, they're on the job, but it's obviously the terrain and all of that is pretty difficult. And the winter this year has been very, very harsh as well. But, just to think of a town which was decimated, lots of lives lost in that, not so much in the town, but in the because of the dam and we are talking about the Tista Urja Dam, which was 1200 megawatt, hydropower. That was taken away with the ferocity of the water volume which came from South Lone Lake. Now, estimates of the volume, 6 million cubic meters of water, which actually poured out of South Lone Lake. As was already alluded to by Miriam, that perhaps what led to the Gulf was not just that, it really the rise of the water and suddenly you found that, it kind of breached the moraine and started spilling over. It was more something like a landslide, and I think satellite imagery has kind of points in that particular direction. But what is interesting is that till today, I don't know if too many people have done any kind of research as to what really happened out there. Maybe there is something that I have missed out, but nevertheless, we know that a huge amount of water from about over 17,000 feet dropped to about 6,000 feet over a 62-kilometer stretch from South Lonak to Chungthang. And Chungthang being a tri-junction, kind of from where you can turn right towards, if you're driving up, you turn right and you'll move to Lachung. And then if you turn left, you drive to Lachin. But now, today, the people of Lachin have to move from Chungthang via Lachung, go all around. There is a pass at about 18,000, Donkala Pass, and then they come down to Lachin from the other end. So that itself is a huge amount of travel that they have to undertake. And, I have recently written to the Chief Electoral Officer of Sikkim saying that you might as well, for those non-resident Lachin folks, they need to cast their vote, and you should open up a EVM counter polling booth in Mangan itself, so that they don't have to traverse that huge part. The cost of food and fuel has gone up dramatically because just a small truck, a small Jeep that needs to go across is now costing something like 25,000 rupees. So imagine what the state of affairs as far as the people from Lachin are suffering. And they have also been protesting, and about why it is taking so long for the government, the Border Roads Organization, and others to actually start to connect. So there is a place, they'll have to traverse a couple of hours by foot if they want to come down to Chungthang, because some part of it is now, you can take the vehicles up. Now, the point is, so as this water came and with all its ferocity, taking down all kinds of material and all the debris, and it breached the first dam. And the first dam, it's very interesting that they hadn't gotten the. So here is what I know, Miriam. We all talk about early warning systems. But if the early warning system doesn't work, if the early warning system fails, and if people are not trained to even take action immediately, then you not only lose time, you lose that precious little half an hour for draining of the reservoir of this particular dam, which was actually working at that particular time at 120% capacity. So you can imagine that the dam was already very full. And here you have this huge amount of water. And it's not like in Norway that, we have another kind of system to, get hold of that particular water. So this rush and and the huge force with which this water came along ended up in breaching the dam, and then that was it. It just went down, and by that time, the NHPC dam further down in Dikchu, thankfully, was opened up, and so there was a little bit of, I think, that dam wasn't breached, but the water did overflow. There, one of the persons who again was responsible for lifting the gates, he lost his life. There was a young lecture boy, and there were two of them. One managed to escape by the skin of his teeth. This particular young boy, he just couldn't make it. But here again, that's why we have asked for an investigation as to why the gates could not be, they were not able to be opened up by the computer controlled person, because that person was missing at that particular time. So that's why these young boys had to go and actually do a manual job. Now, this is some of the sad state of affairs. But, what has happened in terms of impact is, whatever the government says, the numbers don't seem to add up in terms of fatalities. The fatalities, because we know that a lot of shanties have been just swept away, they had no chance. There was nobody to tell them that this kind of huge flood is coming and to run to safer ground. They were taken away with, the people were taken away with the people who migrate to Sikkim, work along the banks, because, sand mining and all kinds of other things that are needed for construction, they are working in that particular area. But there's another side to it, which I'd like to share with you on the impact side is, in the Singtam and Rangpo, especially, which is the border town, and perhaps a little further down in the West Bengal side, people have also built large buildings in collusion with maybe the authorities or whoever in the floodplains. Now, this is a very, very serious matter, because somewhere down the line, we'll have to work out a system, because if we have to learn anything, then one thing that we have to learn is that these floodplains are needed. And if another gulf happens, which inevitably it would, with the kind of climate change and the temperatures that are rising, we are definitely going to see more such disasters in the future. So we really need to ensure that there is no construction in the floodplains, but because the people who actually lost their lives are the people who had built and were living in the floodplains. So this is something which is tragic, but at the same time, there is a lot for us to learn that in the future, such like activities must be curtailed, regulated, and monitored. So all in all, I think Sikkim lost maybe estimates are anything from 5,000 to 15,000 crores. At least 14 bridges were lost. The main bridge linking South and East Sikkim was taken away. So there were those two bridges, the one I alluded to in the beginning where a young boy lost his life. There was another big bridge very close to another, I think it's Teesta Stage 4, dam by NHPC. They were doing some tunneling work. It was very close to that. So now with these kinds of damages, there's been a huge hit on the economy of Sikkim. Today, we find that the tourism potential or the tourism realization in terms of numbers visiting Sikkim has dwindled. We've also seen that people who wanted to go to see Guru Dangmar Lake, and especially Guru Dangmar Lake, that set of people are not coming. The North Sikkim, in fact, is totally, you can say almost cut off, because it now, what used to take about 3 to 4 hours is now taking anywhere up to 8 hours. So tourist traffic in that particular area is also almost halved. So this just goes to prove that we can build a huge amount of such kind of dams and hydropower, etc., because obviously the state would like to get the revenue by monetizing some of these natural assets. But the way I think we're going about it is we really need to re-examine. And whether the dam which was built at Chungthang was really a good idea or not also needs re-examination. And so in an article that I had written for The Wire, on the 12th, I think on the 8th or 12th, immediately after the Glof event, I've requested that some kind of a forensic auditing of what went wrong. And I'm so happy that to hear Dr. Sen saying that these things can be done. I mean, one can look at the seismic events just prior to, maybe a month prior to the seismic events, month prior to the Glof event. Was the landslide in the Glof Lake, in that particular area, in that lake area, was it triggered by some kind of a, because we know there was absolutely no cloudburst. But at the same time, what triggered that? Was there a tremor? Immediate preceding that, there was a large enough, I think, earthquake in Nepal. And that, if something happens in Nepal, we get to feel it as well. So we really need to do those kinds of studies and see how we can now start building up the kind of policies, but not just policies, but also to see that, they relate to the communities downstream in much more engaged manner. What I can say is that we did talk to lots of people in a place called Dikchu, whether early warning systems were in place. And it seems that training for early warning systems in that particular locality had been done. And so when the warning came, everybody moved to higher ground, which was the way in which they had been taught. It was done almost drill-like, and nobody lost their lives, though a lot of houses were damaged and swept away in Dikchu as well. But downstream, that is where Singtam is, this town in Singtam, as well as Rangpo, no such luck there. and lots of people on either side of the river lost their lives. So estimates are put at something like 2,500 by the government, but I think we do believe that it's much, much more. So I hope I've been able to do justice to
Thank you, Mr. Rai.
kind of impacts. And I think these are negative impacts, but like everything else, we can learn from them, and we can put not only the early warning systems, but things that I think a lot of, I think the people of Sikkim, unfortunately, we are the ones who suffered, but it should be definitely a warning and a learning for the rest of the Himalaya. Thank you very much.
Thank you, Mr. Rai. Thank you. अभी आप लोगों ने मिस्टर राय को सुना, और हमारे पास 3 ऐसे एक्सपर्ट हैं जिनका एक रिसर्च है पूरा इस तरह की, जो इतनी भी दिक्कतें हैं हिमालय पे, जो क्लाइमेट चेंज का इम्पैक्ट है। हमारे साथ एक दूसरी एक्सपर्ट हैं जिनका अर्ली वार्निंग्स पर इतनी अच्छी पकड़ है, और उन्होंने बताया कि कैसे सिक्किम के बारे में 2016 से 17 से पता था। और तीसरे हमारे एक्सपर्ट हैं जिन्होंने इसको झेला है, जो थे जिन्होंने इसको ग्राउंड पे देखा है। तो अभी आपके पास मौका है, आप लोग कुछ अगर सवाल पूछना चाहते हैं, 1-2 सवाल अगर किसी के पास हो, तो आप तीनों एक्सपर्ट्स में से किसी से भी पूछ सकते हैं।
Thank you. I have a question for Dr. Jackson. As you talk about many glacial lake outburst flood related issues, do you have any regional cooperation initiative for these issues in the Hindu Kush Himalayan region, especially in Indian Himalayan region?
Was the question, do we have any cooperation?
Any initiative from ICIMOD side?
We have a lot of cooperation.
For the regional cooperation on issues relating with this.
Yes, we do, certainly with government organizations. So with the Department of Hydrology, Meteorology in Nepal, and the Department of Risk Reduction Management. Also the similar organizations in Bhutan and similar in Pakistan. In India, not so much. We did actually have a meeting with the Ministry of Earth Sciences a couple of weeks ago. So we, on a fairly casual level, like I was talking about Ashim Satarlat, who'd written a lot about this, and modeled the floods that could happen before one actually happened. People like that. So academics in India, we have a lot of contact with, and several of them are working on GLOFs, GLOFs in Kashmir, for example. So we have quite a few contacts in India as well, but for some reason, not so much with the government agencies in India as we do, in other countries like Nepal and Bhutan. So we would, we're definitely trying to work on, and we have a couple of contacts that we're trying to follow up as well. But we've also generally been thinking, we need to work a lot more in Nepal and Bhutan and Pakistan on these things because they need our support. And India and China, things are generally going a lot better, but not always. There's always things that can happen and take you by surprise. So I think we certainly need more contact with government agencies.
My question is, we all also know that the Himalayan region is an earthquake-prone region. So already there are early warning systems in place. Don't these warning systems pick up even if there are any hydrological, apart from the seismological, don't these systems have sensors which can actually pick up any kind of tremors related to a hydrological activity, which obviously those vibrations should be felt on the ground level also, right? So are they not so sensitive? Is it what went wrong, or we don't have that many systems network which actually couldn't trigger out any warning systems?
Yeah. Maybe this question to me.
Yeah.
You are correct that for some sort of even glacial avalanche, I showed example that they are recorded into the seismological data we call seismic seismometers. So they are recorded over there. So only thing, whenever we deploy any sort of network, the purpose is specific. So we have been doing that early warning for the damage pattern of the earthquake. We are not doing any prediction of the earthquake. We have not done, and anywhere in the world, the prediction of the earthquake is not there. Only when the earthquake takes place, whether that earthquake has magnitude more than 6, whether the earthquake has taken place at a large distance, so that the destructive waves reach later. So if we have that primary wave and the secondary wave difference, time is 10 seconds, 15 seconds, so we can have that. But we have not any system anywhere in the world for the prediction of the earthquake. For the early warning, whether that earthquake can destroy in a particular area, the damage pattern, for that early warning system is working. And sometimes that phenomena will have the time limit of 15 seconds, 20 seconds, 30 seconds. So within that time frame, whether you will be able to do anything which will trigger other phenomena besides earthquake, can trigger that cascading effect Madam also has shown. It can lead to some landslide. It can lead to some sort of artificial lake formation. The lake can cause some sort of flash floods. So within that 30 seconds, 20 seconds, depending on where that earthquake has taken place. If it takes long distance, it will take the damage wave from the event of the primary wave to secondary wave. Secondary wave cause the damage. So the time difference 10, 20, 30. Japan has been successful, but that is to protect people from getting damaged, but not for the prediction. So here we are talking about if glacial lake is going to be burst, glacial avalanche is going to take place, and if it is due to an earthquake, then that phenomena, I showed an example, there will be some sort of activities and tremors that can be taken into consideration, and that's what we have been doing into the early warning. The prediction of the earthquake, we have not been able to make it. This is a sure shot you have to know.
Can I come in here? Sudhirji, can I come in?
Yes, please.
So, these early warning systems we've been hearing about early warning systems, and also I've seen some of the early warning systems put in place, But the unfortunate part is the maintenance and its use is, because these things happen so infrequently that everybody is lulled into a sense of, everything is going okay. And therefore, nobody is really, looking at the data or whatever and analyzing it and saying, all right, maybe we're going to have something coming up shortly. So the early warning system is not a panacea. The early warning system is just to give you an idea that, okay, we're measuring a few things, but we need to make sense of it by also maybe visiting that particular place every now and then. I know that from 2019 onwards, there was just one expedition that went to South Lonak Lake. When I think, we should have had many more expeditions and spent a lot more money, because suddenly the money comes when the lake bursts. This particular company that runs this power plant was able to fork out quite a bit of cash. But look at the way that they were not, giving priority to these early warning systems and saying, let's mitigate the risk somewhere. So there's a governance issue as well. And I think we need to connect all these dots right across the Himalaya, whether it's research, it's policy, and governance. We need to see that all of these things come together so that, all of us benefit in terms of, these events will happen, but we would be able to adapt as well as mitigate some of the downstream disaster and loss of life and property. Thank you.
क्यों एक सवाल मेरा भी है, मतलब मैं भूल गया था शुरू में पूछना कि करीब 55% इलाका हिमालय का भारत में आता है, 30% नेपाल में, 10% पाकिस्तान में, कुछ हिस्सा चीन में है। तो ये जो साउथ वेस्ट मानसून है और जो मैदानी इलाके हैं या जो नदियों का फ्लो है, जो इम्पैक्ट ऑफ क्लाइमेट चेंज ऑन हिमालय है, उससे क्या इन पर कुछ फर्क आने वाला है?
देखिए, आपके क्वेश्चन जो है, मैं थोड़ा हिंदी बोलने की कोशिश करता हूँ, हो सके ठीक होगा। तो साउथ वेस्ट मानसून तो पैदा हो रहा है, इज गोइंग टुवर्ड्स नॉर्दर्न डायरेक्शन, हिटिंग द हिमालय। एंड व्हाट एग्जैक्टली हैपेंड इन द लास्ट ईयर अक्टूबर, जुलाई, अगस्त इन Himachal Pradesh and parts of Uttarakhand, that there was weak westerly disturbance and then southwest monsoon, and that in the confluence, they made heavy rainfall into Himachal Pradesh and that parts of Uttarakhand, and they led to the landslides. All of us know and what exactly happened into that. So when always we are relating climate change and its impact related to the that area, whether it is a flash floods, whether it is related to landslides. But one other thing also need to look into, that it is not only the climatic factor, we have to look into the other factors also when we assess the hazard in a particular region. Particularly, I am just giving the example of the Simla. If you look into the surface rocks, they're made up of loose and weather rock. And if you look into the houses built up, Sarah has also rightly pointed out, the buildings, the heavy construction material, and the, I will say, the drainage system was also not proper, that water also percolated downward. So in the top 0.5 meter, that soils was soaked with the water by the household water thrown from the toilet, thrown by the kitchen, and the rainfall, and that cutting of the trees, that in the slope region, roots of the tree play a very important role for the production of the slope failure. So all this combinedly, one factor can trigger it, but other factors also playing role, small. And when it reaches to a critical stage, that other small factor can cause havoc. And that's exactly happening. So always the climatic factor is there, but along with the climatic factor, we have understood in holistic way, we have to look into the geomorphology, structure, tectonics, anthropogenic impact also combinedly to look into the how much load is being exerted into that area and whether the rock and the foundation is enable to sustain that load or not. So this is in a perception, but definitely in the present climate change scenario, we have been experiencing the extreme events like heavy rainfall, heavy snowfall, and that are also leading to some sort of disasters.
थैंक यू। एक मिनट, अब ऐसा करते हैं कि दो तीन जो भी सवाल हैं वो एक साथ ले लेते हैं, क्योंकि अगला सेशन लेट हो रहा है, तो हम सारे सवाल एक साथ ले लेते हैं।
Okay, so let me.
हाँ, अभी आपके इधर से पहले हो जाए, फिर अब आपसे।
Dr. Sain can answer this because you were the last one to make this comment. But I think this has been the refrain all throughout, that mankind has been going wrong in tackling climate change and in the way you construct buildings in the hills and all that. But I was just looking at the figures here that 100. You in fact said our ancestors did it so well, and we are not doing too well. So that's where I want to come in. That our ancestors of even 100 years ago. 100 years ago, there were 2 billion population, and now we have 8 billion population. So what they were tackling is not the same as what we are tackling. So I don't think there's any comparison there. So I think this is what we've been missing out all throughout. That is also a population problem. We keep talking about exploiting nature. We keep talking about.
Sir, question थोड़ा सा
this is the question. This is the question that we've been missing out on the growth of population. We're just talking about the climate change. Maybe it's not climate change always. Maybe it's also population pressure, which is making us do what we are doing now. But this has not been answered. This is my question. And P.D. Rai also can answer. He said it's a governance issue. Whether it's always a governance issue or whether it's that this population angle is also there.
सर, जो बताया जाता है कि जो नेचुरल डिजास्टर वगैरह होता है जो हिमालयन रीजन में, ये सब कभी कभी जो आर्टिफिशियल रेन वगैरह करता है, जो क्लाउड बर्स्ट होता है जो चाइना की कुछ करतूतें बोल के ऐसे आता है, तो क्या इसमें सच्चाई है क्या?
Hi, my name is Safina. So I am from Kashmir. I have been reporting Eastern Ladakh. So I just want to know, since the climate changes from two parts, it's from China and the India. In Eastern Ladakh, particularly when we talk about the Tibet, so it's China. So when we talk about Eastern Ladakh, Changthang, so it's in India. So will the climate change and these early warning signs change the face of LAC? And second is like, I just want to know from Dr. Sen, you work in the Eastern Ladakh on different projects, like on artificial glaciers and all. So what is the scenario right now, the glacial lakes in Eastern Ladakh, and people don't want to move right now because they want to stay there for the sixth schedule and some other reasons. So if there would be constructions and if there will be a forced migration or the forced dislocation, so how would you see in next 20 years the face of Eastern Ladakh? And my question to Jackson is like, on the other part, how do you see how China is coming up with unabated construction on other side, which we might face in the next coming 2 decades?
I have a quick question. Is there any effort at measuring the hydrological potential of the Hindu Kush Himalayan region so that there's like a cap on how many dams can be built for hydropower or how much construction can be made? Is there a ceiling limit? Is there any study? Is it even possible at all to measure something like that?
Okay. There are 4 or 5 questions. I will try to answer some of them, and Madam will take some others. Coming to, sir, your question that traditional knowledge and in the present day explosion of the population, definitely the traditional knowledge during that era, the population was low and now it has flooded, definitely. But the knowledge, whatever they had, and in the present day modern knowledge, what we want to say that there should be some sort of synergy. We should not simply neglect that. But doesn't mean we are not taking care of present day population. In the present day population, that's why our problem is also severe. That time problem was also not that severe. So we have to look into their knowledge and the present day, whatever modern science, modern technology is telling combined. So that's what we are telling. This is one aspect. You have other question also? No? Okay. So your question that China's I'll say interference or in our territory, I think this is a very important issue and question. We should have transboundary some sort of discussion government to government, because we are talking about the issues which is not taking place in India only, Indian Himalaya. Even if we talk about glaciers, talk about glacial lakes, even if we rainfall, heavy rainfall, this can happen any other country and impact may take place to other country. So we should have the transboundary forum or maybe some sort of Himalayan council is required where they will be the member, and the member country would understand that what sort of phenomena is going on into the entire Himalayan region, and that can make impact not only your country, our country, in country. So transboundary or council type of things are required. And Madam question was Ladakh regarding artificial glacier, other things or? Yeah. Yeah. I understand your concern. In the beginning also, I pointed out that whenever there is some sort of constructions, we need to definitely have some sort of impact assessment of that particular project, whether it is making impact to the society, whether it will make impact to the environment. Without that impact assessment, even before the construction starts, we should also have some sort of assessment that which way we are going to have constructions into that area. Plus, during and after also, we need to monitor, we need to assess, and time to time, even if something happens in a particular region, we cannot think that, okay, for developmental purpose, we have made it and it is producing. We also need to understand in the future, after 10 years, 15 years, 20 years, what sort of things are going to happen. So your question in that way, definitely in scientific way, we have to assess whatever constructions are going on, what impact it may make to the society, what impact it may make to the environment. And in this region also, 2010, there was cloudburst, and in Ladakh also, which is considered is a cold, arid region, and there also it happened into that region. So in the climate change scenario, really it is very, very difficult to predict anything, and anything is happening in somewhere where we are not expecting them. I just give an example into this. Recently, Indo-Nepal border, Dharchula, there are two rivers, and there was heavy rainfall that particularly we can call cloudburst. More than 110 millimeter rainfall takes place per hour. We call it cloudburst. And those two rivers were in confluence, and the water could not be drained out properly. The drainage system was not proper. So the water receded back. And the bank of the rivers, there are houses, villages, and those villages got drowned into that region. So again, in any city also, we have to look into, if there is even in Mumbai, if there is a heavy rainfall, drainage system is not proper, the rain can be drained out immediately. So there will be flood. Bangalore also experienced, the lake have been encroached. The lake area has been reduced. Though whatever, if heavy rainfall is there, the lake is not able to accumulate them, and it is getting flooded. So we need to understand all this urban development, how much impact it can make to the society if there is a heavy rainfall under the influence of the climate change. So all sort of things are going on, studies are going on, and definitely we need to make a concern in those directions. Thank you very much.
Please, नहीं अभी वो नेक्स्ट सेशन शुरू होना, आप डिनर में पूछ लीजिएगा, डिनर के वक्त हैं एक्सपर्ट. अभी एक क्वेश्चन ऑलरेडी पहले से पूछा हुआ है, उसका जवाब देना है उनको.
Yeah. There's a few things I want to answer here. And one is the idea of a Himalayan Council was brought up. And actually, this is something that already exists. That ICIMOD does have a Himalayan Council of Ministers. This was started in 2020. There'll be another meeting in 2024. And the idea is that this would work on these kinds of transboundary issues. So you questioned about, China, if China's doing construction across the border. I gave an example where if there's a hazard on the other side of the border, you can't go in and do construction yourself. And also the opposite is true. If they're doing something that will affect you, you have very little, sort of power to anything about it. But we're hoping that, with good dialogue and this Council of Ministers will help. The question concerning, how China is with early warning systems, they are doing a lot. I mean, the whole, way of looking at water resources is incredible. They have basically every river, 100-meter stretch or so has a person responsible. And I couldn't believe this when I heard. I said, this would take so many people. And my Chinese colleague said, yeah, we've got a lot of people, so they really, the kind of control they have over it is just, and monitoring, it's just amazing. But they're also quite willing to spread the knowledge. So we are trying to do, capacity building in this at ICIMOD. I also wanted to come back to the question about the early warning systems. Can you use one for hazards, also for gloves? And you do certainly see a seismic signal if you suddenly have a lot of discharge in a river. But if you want an early warning system for gloves, you should do that. You can get an earthquake that triggers a glove, or you get an earthquake that doesn't. You still want to know about the earthquake because there's other reasons it might cause damage. But in terms of a glove, an early warning system, you either put it in the lake and you see if the lake level drops, or you put it in the river and you see if the discharge increases, or you might do both, which would be best. And if your concern is gloves, that's what you should concentrate on. If your concern is earthquakes, then you have another system for that. This isn't really a good area to combine things and try and save money. Just, you could have one station that's doing both, but they're different sensors. So you need to really make sure that you're doing the right tools for what you need.
मेरे ख्याल से आप लोगों के मन में और भी बहुत से सवाल होंगे, तो अभी डिनर के वक्त आप अपने एक्सपर्ट्स रहेंगे वहां पर बात कर सकते हैं. थैंक यू मिस्टर सेन, थैंक्स मरियम, थैंक्स मिस्टर अये, थैंक यू.
Thank you.